Hello friends, welcome to Electronics Engineering Exclusive. Today we will discuss part 2 of the measurement subject, that is systematic error analysis. We have already covered the introduction to error parts in our previous lecture. You can watch that video from our channel. Also, the content of this video is limiting error analysis, limiting error in combination of quantities. These two topics are asked in various competitive examination as a numerical question, and we will solve some numerical also with subsequent theories. So let's start. We have to analyze the limiting error. Before analyzing, we have to know what is limiting error. Limiting error is basically specified by the manufacturer itself, and it is also called guaranteed error. And you can see when you buy some resistance, you get some strips on the last of that resistance that shows the tolerance of that resistance. That is limiting error. So mathematically you can say that the measured value is equals to true value plus absolute limiting error. This value is absolute limiting error, which is showing the deviation from the true value of the measured value. And we have already defined the deviation from the true value is called the error. So it is a limiting error. Absolute in terms because it had some unit. The absolute error is defined by the manufacturer. It does not convey any important information. So as per our use, we have to define some other term, that is relative limiting error, and that is the ratio of absolute error divided by the true value. So as the true value changes, relative error changes, but absolute error does not changes because it is defined by the manufacturer. So as per our use, we change the relative error, so that give you a better picture. So we use relative error. Percentage can be calculated by just multiplying by 100, everybody knows that. And now from 2 we can rearrange it as the del A is equals to AS into ER. Now here del A is the limiting absolute error. Here we replace this del A and we get this form. Some numerical is asked from this form also, that is measured value is equals to true value 1 plus minus ER. But more important form is this, that is relative error is equals to measured value minus true value divided by true value. So here we are getting a formula for percentage relative error, that is measured value minus true value divided by true value into 100. That is very important for solving the numericals. Two important conclusion we can draw from this discussion, that is absolute error is always constant because it is specified by the manufacturer. So it is irrespective of deflection. Next is the relative error. Relative error decreases with the increase in deflection. Deflection increases, the true value increases. If the true value increases, the relative error decreases. That's why we have always told take the reading of the analog instrument nearer to the full scale. This is the reason, because as the full scale reading increases, the true value increases, the relative error decreases, and that is good for any system. Absolute error does not changes with the deflection. So three important formulas for solving the numerical. We have already discussed the relative error formula. Now sometimes some substandard terms can be used in the questions, and they ask to solve some relative accuracy or percentage accuracy. So relative error can be explained as 1 minus ER. ER here is relative error. Percentage accuracy is 100 minus that percentage relative error, that is calculated from this formula. So now let's solve some problems from these formula. Here we can see the question as during measurement of the voltage in particular setup, the reading of the voltmeter is found to be 80 when it is actually 81 volt. So these two values emphasize because they are showing the measured value and true value, and we have to find all the terms we have already defined. So absolute error is just the difference of both. We get 1 volt, and these 1 volt is del A. We have to replace it in the relative error form, and AS is here is true value, which is 81. We get the relative error, and relative accuracy can be calculated by subtracting it from 1. Similarly, if we get the percentage of this ER and subtract it from 100, then we get the percentage accuracy. So that is one form of question asked. The next form is they ask for the limit values. So in this question, the value of capacitance of a capacitor is specified as 1 microfarad plus minus 5% by the manufacturer. The limits between which the value of capacitor can be guaranteed is, you have to calculate the limits. So here we can say that 5% is the relative error, so ER is equals to plus minus 0.05. And also I have explained this formula earlier, that measured value is equals to true value 1 plus minus ER. So we have to just replace the value of ER. For minus sign it will give the lower value, for plus sign it gives the upper value. So we get the limits of this. Now limiting error in the combination of quantities. The quantities can be given in sum, subtraction, product and quotient. So we have to just find the limiting error of the resultant system. So first is sum or difference of two or more than two parameters. So let's x1 is, so let x is equals to x1 plus x2 plus x3. Here del x, that is error, absolute error, can be explained as plus minus del x1 plus del x2 plus del x3. The absolute error of individual system get added to get the resultant absolute error. But we are more interested in relative error than in absolute error. So relative error can be calculated by dividing it by true value. This form is not very good to solving the question. So we have to redefine the form by multiplying this term by x1 in numerator and denominator both, and doing the same for other two terms. We get these form. This form is better than this form because this ratio del x1 by x1 shows the relative error of system 1 multiplied with x1 by x. Similarly, in this, del x2 by x2 shows the relative error of system 2 multiplied with x2 by x. Similarly, in the third case. So it is a better picture and we can solve the problem easily from this formula. You can see in some examples. So let's discuss an example. Two resistance of values R1 is equals to 100 volts plus minus 2% and R2 is equals to 200 ohm plus minus 1% are connected in series, then the value of the resultant and the percentage error will be. The first method is to calculate the del R1 and del R2 and then sum up to get the resultant absolute error, which was explained in this form. When we get del R, we have to just divide it with the true value to get the relative value. So this is the conventional method. To get objective approach for this question, we have to use the formula which we have derived earlier. Here you can see that del R by R is equals to plus minus R1 by R into del R1 by R1. Since del R1 by R1 is given 2%, we have to just replace it by 0.02. And similarly, del R2 by R2 is given as 1%, so we have to replace it with 0.01. Adding them, we get the final answer. So both are correct, but when around 10 parameters are given, then the first formula is very lengthy, so you can use the second form which will give you the answer very directly. Sometimes product or quotients of the parameters is given, like x is given as x1 into x2 into x3, and if you wish to find the relative error, we have to take the log on both sides. After taking the log, we have to differentiate. We know that differentiation of log x is 1 by x and the differentiation of x is del x. So we get this form, del x by x is equals to plus minus del x1 by x1 plus del x2 by x2 plus del x3 by x3, because there are 3 parameters and so on if more parameters are there. You can use the formula directly. Similarly, sometimes power of a factor is given, that is x is given as small x raised to the power n. So again the procedure is same, take the log and differentiate. We get the error as del x by x is equals to n into del x1 by x1. So let's discuss one example. Here error in voltage is given as 0.5 and error in resistance is given as 0.2, and they ask the error in power. So we know that power formula is V square by R. So here we are using the form of this, that is power of n factor, that V square is given, and we are using quotient because V divided by R is given. So applying that formula, we get 2 because of the factor V square. So 2 is multiplied with 0.5 because the error is given is del V by is given as 0.5 plus 1 into 0.2, and we get directly the power form. We have covered 2 topics on the measurement subjects. We are providing short notes on our Facebook page of the topic we have already covered. So you can download it from our Facebook page, and the link of the Facebook page is given in the description box. We will discuss random error analysis in our next lecture, which will come tomorrow. If you want regular notification from our channel, you can subscribe our channel and you can like, share and comment on this video. Till then, bye bye.